Welcome you all for this today video lecture. Myself Sherin Glory, Assistant Professor from Department of Computer Science and Engineering. Today we are going to discuss about Huffman coding from greedy technique. So what is this? In greedy technique, we have two types of coding. So there is encoding. What do you mean by encoding? We are going to convert the data into illegitimate format. Okay. So in the types of encoding, we have two types of encoding. One is fixed length encoding. Another one is variable length encoding. So what is this fixed length encoding means? We are going to assign binary bits for the characters. Okay, so the number of bits in the character binary bits in for the characters will be same for all the characters or for all the letters. Whereas the variable length encoding, the number of bits or binary bits we are going to assign or we are going to find or we are going to encode will be varying depend on the frequency of the occurrence of the characters. Okay, so that is the basic difference between your fixed length and variable length encoding. So here the number of bits is same for all the characters, whereas here the number of bits is different for the all the characters. So that's what they have given. Each code word is of same length, whereas here each code word is of different length. Okay, so see here they have given some set of characters and the frequency of occurrence. So A is occurring 45 times in a Word document, or B is occurring 13 times respectively, C, D, E and F is given. So for all the irrespective of the occurrence of these characters, the number of bits assigned here in your fixed length coding remains the same. See here I have assigned only 3 bits for all the characters, whereas in your variable length encoding, the number of bits is quite different for each and every characters. It is quite different. Okay. So that is what we are going to see. So this Huffman coding falls under this variable length encoding. It is not fixed length encoding. So what is this Huffman code? This is a lossless data compression algorithm. As I said, it is going to use variable length encoding, and variable length codes are based on the frequency of the occurrence of the letters. So most frequently occurrent character will be having minimum code length. Say you have seen in the previous slide itself, A is occurring 45 times, but the number of bits assigned for that A or the encoded value is only 1 bit. Okay, vice versa we will be assigning. So similarly, least frequently occurring characters will be having maximum code length. So to prevent ambiguity in decoding, it uses prefix-free codes. So what is this ambiguity? Repetition of same codes. So we are going to use prefix-free codes. Okay. So this Huffman encoding or Huffman codes consist of two parts. One is first thing is I have to build an Huffman tree from the given input characters based on the frequency of the occurrence. Okay, and then I have to, after constructing my Huffman coding tree, I have to traverse the Huffman coding tree and assign the codes for each and every characters. So these are the two main parts we are going to concentrate or we are going to perform while constructing, while assigning the codes for the characters. Okay, so as I said, what are all the steps to construct my Huffman coding tree? First one is initialize n nodes. So node trees, label them with the symbol of alphabets given, and then I have to record the frequency of each symbol in its tree from root to indicates the tree weight, and identify the two trees with smallest weight and make them as left and right subtree of new tree with their root as the sum of their frequencies. Okay, and repeat the step until I get a single tree is obtained. This is what we are going to do. So once the tree is obtained, we are going to traverse the tree corresponding to the characters, and we are going to assign the code words or codes for each and every branches, and we are going to find out the code length or code words for each and every characters. So we will see a problem and we will see how it is working, how we are going to perform. So here in the example they have given 5 symbol alphabets, that is A, B, C, D, and then underscore is given, and they have given also a frequency of occurrence. So frequency of occurrence is 0.35, B is 0.1, C is 0.2, and D is 0.2, and underscore is 0.15. So now as my step says, what I have to do, I have to identify the least probability, least frequency of occurrence characters. What are all the, here it is 0.35, 0.1, 0.2, 0.2 and 0.15. So which is the least two probability of occurrence I have? One is B, another one is 0.15. So I have identified that. Now what I need to do was I have to add the probability or frequency given of the least two probabilities should be added together. So 0.1 and 0.15 will be added together. Okay, so to make it as easy, first what I am doing is I am arranging it in the increasing order. Then I am going to add these two values together and I am going to find out the what is the new frequency value. Okay, so now after arranging it, choose the two minimum values. As I said, I am going to form a new tree. So now my new tree value or new node value is 0.25. Again, these two has been added together and I have got this 0.25. So I have to see a proper position for this 0.25. Whenever I performing an addition operations, the resultant value has to be again place it in the proper place according to the increasing order. So what will be the proper place for this 0.25? It will be coming before my 0.35. That's how then only it will be in proper increasing order, isn't it? So what I am going to do was I am going to arrange it and then again in an increasing order. See here, after arranging it in increasing order, this is now my tree. Again I have to repeat the process. So again I have to repeat the same process. Now I have only these values. Again the least two probabilities are C and D. Again this will be added together and the resultant value will be found out, and again that new value will be placed in an increasing order. Okay, so I have chosen the two minimum values. I am going to find out 0.4. Okay, so 0.4 came by adding 0.2 and 0.2 of C and D. Now I have to place my 0.4. Where does my 0.4 will come? So according to the increasing order, it should be after my, it should be at the beginning of my 0.35, isn't it? So I will be having 0.25, 0.35 and 0.4 in the next slide. Okay, fine. So now see, I have got this. So again I have to repeat the process, choose the two minimum values. So in this, these are the two minimum values. Again this to be added, isn't it? So this to be added. So this to be added 0.25 plus 0.35, I will be getting around 0.7. Okay, so this 0.7, sorry 0.6 will be again place it in the increasing order. So place it, by placing it in increasing order, it will be coming after my 0.4. Okay, so now I have got an tree like this. So finally I have only two nodes. I have been left out with only two probabilities. So this will be connected with an root node. Okay, so this is what my tree finally. So now I have to assign codes for my branches. Now I have constructed my Huffman coding tree. So next I have to assign codes. What I am going to assign? I am going to assign 0 for the left branch and 1 for the right branch. Okay, so then I need to traverse my tree. That is what my second step says. So for C I have to traverse, okay, C here, D here and B here, A here and hyphen, sorry, underscore is here. Now I need to traverse. So how I am going to traverse? From the root to that corresponding node. So for C it is this way. So what are all the code words it come across? 0, 0. So that's what they have given here. For D this way. Okay, so what are all the code words it is come acrossing? 0, 1. For B it is this way, so it is 1, 0, 0, isn't it? So 1, 0, 0. For A this way, isn't it? From root to A, what are all the code words it come across? So it is 1, 1. And for underscore it is 1, 0, 1, isn't it? So I have found out my code words. So that's all. See here, the number of bits in each and every characters is simply different, isn't it? As I said, as the frequency of occurrence is more, the number of bits is less. So A only had the highest frequency of occurrence. See the number of bits here, it is only 1, 1. And we had the least probability of occurrences underscore. See here the number of bits is 3 bits. B and underscore are the least probability of occurrence, isn't it? So see what is the thing they having number of bits here is 3. So to calculate the average code word length, the formula is frequency into code length divided by summation of frequency. What is the frequency given? They have already given in a table. Into code length. Number of bits is nothing but the code length. So for this 2 into 0.35 plus 3 into 0.1 plus here I have 2 bits, so 2 into 0.2 plus 2 into 0.2 plus 3 into 0.15. So code length is nothing but number of bits in each and every characters divided by summation of frequencies. So summation of frequency is 2 plus 3, 5, 5 plus 2, 7, 7 plus 2, 9, 9 plus 3, 12. Okay. So substituting that, see here, summation of frequency, sorry, 0.35, 0.1, 0.1. So I will be getting total frequency will be 1 only. So it is 2.25. The next thing is if we have used fixed length coding, the fixed code length will be 3 bits. Okay. So, but here we are having average code length, word length of 2.25 bits. So comparatively, the number of bits used, compression ratio is high in this Huffman coding, isn't it? Yes. So we have to calculate the compression ratio. So 3 minus 2.25 by 3 into 100. So what is the value we are getting? We are getting 25% more than the actual compression ratio what we achieve in our fixed length coding. So that's all about your Huffman coding. Thank you.